Let's practice solving a quadratic trigonometric equation together. While there are going to be infinite solutions to these types of equations, we're going to be just focused on the solutions that fit between 0 degrees and 360 degrees. And when we have to do some rounding, let's go to the nearest tenths place. To get started, I'm just going to start by rewriting the equation. So we have 5 multiplied by sine squared of theta, plus we have 6 times sine of theta, and then we're going to take away 4. And this is going to be equal to -5. Now to make things a little bit easier, let's go ahead and use some u substitution here. We do have a quadratic pattern, but I'm going to go ahead and say let's go ahead and let u represent sine of theta for the time being, and then we'll make that swap back a little bit later. So making that substitution, we're going to go ahead and say 5 times u squared here. Again, sine squared of theta is just sine of theta times sine of theta, so that's going to be u squared. Plus we're going to have 6 multiplied by sine of theta, which is just u. And then we can go ahead and take away 4 and say that's equal to -5. Okay, so that looks a little bit less scary now. Let's go ahead and set this quadratic equal to 0. Let's go ahead and move everything to the left side. I'm going to go ahead and add 5 to both sides of this equation. When we do that, we end up with the equation of 5 times u squared. Then we have plus this 6 times u, or 6u. And then -4 plus 5 is going to be a +1, and that's going to be equal to 0. So it's nice we have a quadratic here that's in standard form, and we can go ahead and try to factor this, and this one does factor pretty nicely. So if you need to pause to think about factoring, feel free to do so. I think this is going to factor into 5u, and then it's going to be +1 for this first binomial. And then for the second binomial, I think it's going to be just u plus 1. Now to solve for what values of u are going to make this true, we have to set this equal to 0. So we can go ahead and say, okay, let's set 5u plus 1 and set that equal to 0. Then we can solve this by subtracting 1 from both sides of the equation. And when we do that, we are left with 5u on the left side, and that's going to equal -1 on the right side. And then we can go ahead and divide both sides by 5 here. If we go ahead and do so, then we're going to end up with saying that u is going to equal -1/5. For our other binomial, we have u plus 1 is equal to 0. So I'm going to copy that down of saying u plus 1 is equal to 0. And to solve for u here, let's go ahead and just take away 1 from both sides. And we find that u is going to be equal to -1. So going back to our equation here, we can say that u is going to equal -1/5, as well as u is representing -1. Now, let's go ahead and do some back substitution here. So remember what u actually represented. We said u was really going to be sine of theta. So let's go ahead and rewrite that back into the equation. So substituting in sine of theta back in for u, we can say sine of theta is going to equal this -1/5 for a ratio. And then we can also say that sine of theta is equal to this ratio of just -1, or -1:1. Now using our arc trig functions to find out an angle measure, we can say that theta is going to be equal to arc sine of this -1/5. Okay, we can use a calculator for that in a moment. And for our other one, we can say that theta is going to equal to arc sine of -1. All right, plugging in arc sine of -1/5 into a calculator, I'm getting that theta is going to be roughly -11.5 degrees. But remember that we are looking for angle measures that are between this 0 degrees and 360 degrees. So let's go ahead and say that's not going to work, but we can find a coterminal angle by adding 360 degrees onto this -11.5 degrees. If we go ahead and do that, we should end up with an angle measure that's a little bit better for us that we're looking for. So we're going to say this is going to be about 348.5 degrees. This angle would be in the same location as -11.5 degrees, but it fits between our restrictions of 0 degrees to 360 degrees. Then we can go ahead and plug in arc sine of -1 into a calculator, and actually this one you don't need a calculator because this is going to be on our unit circle in a nice location. So if you think about that, hopefully you can come up with theta equals 270 degrees. That would be on the -y-axis at the bottom of the unit circle. Since this is between our 0 and 360, we like this as a solution. Let's see if we can find any more, because I think that the sine ratio of -1/5 occurs in more than just one quadrant. Okay, so 348.5 degrees, we could say, is maybe roughly over here in quadrant 4. If we go ahead and draw that triangle, that would be something that looks like this. And keep in mind, sine is negative in quadrant 4, anything that's below the x-axis where sine is negative. Now, sine's ratio is this negative 1 over 5. Now, sine is opposite over adjacent, or y over that r value. So this is going to be negative 1 in terms of its y value, and the hypotenuse here is going to be 5. So we have one location here. This is going to be 348.5 degrees if we go all the way around to here. Now, sine is going to be positive over here. Sine's positive here, but we also know that sine is negative here as well as over in quadrant 4. So in 3 and 4, sine is going to be negative. So we can also recreate this triangle over in quadrant 3 and basically get the same reference angle here. So we have basically 11.5 degrees as theta as our reference angle here, but we do have a y value of negative 1 and a hypotenuse of 5. So I know this isn't quite the unit circle, but it's a scaled version of it. That's fine. So we have the same ratio of those lengths here. So if we want to figure out this other angle measure, this would be all the way 180 plus another 11.5 degrees. So I'm coming up here with saying that I think theta would also be about 191.5 degrees. This would be a third and final solution for us. In terms of why there's only one way of getting this negative 1 value for the ratio is because that's going to be down at 270 degrees. That's right over here. And so that value, or that point here, is going to be 0, negative 1. There's only one spot on the unit circle where we're going to have that y value of negative 1. So we have our three solutions here that are between 0 and 360 degrees. So we can just summarize and say that theta for our three angle measures here are going to be 348.5 degrees. We also found this 191.5 degrees that also got us at negative 1/5 ratio. And then 270 degrees is the only angle measure that's going to get us that ratio of negative 1. So there you have the three solutions that fit between this 0 degrees and 360 degrees that satisfy this quadratic trig equation. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.